Hello all, my name is Rahman and welcome back to my YouTube channel. In this video, we are going to talk about space complexity and we'll also try to talk about the time complexity. If you remember guys, in the last video, we have talked about frequency count method, like what it is, how it works, why it's used, etc, right? But with that, we have taken this Python program which is going to find the sum of all elements in an array, right? So here we have written a Python program, and with that here guys, as you can see here, we have defined a function known as sum. But guys, basically in algorithms we don't define any functions here, but for explaining all of you, I have just defined that, but here we are not going to define that in the algorithms. Okay, now here we have a variable known as s, which is equal to 0. But in the last video, if you remember guys, we have analyzed the time taken by this algorithm, right? We have analyzed the time taken by this algorithm. Now you may be thinking that why am I calling this as an algorithm, right? So the reason that I am calling it as an algorithm is that, as I said, algorithm is not a subject, it's a type. It's a step-by-step procedure for solving a problem, right? So for solving a problem here we are doing a specific task, right? We are doing solving a specific problem, and that is we are finding the sum of all elements in an array. So here for that we are using this step-by-step procedure for doing this specific task, right? That's why I am calling it as an algorithm. By the way, here I have in the last video I have analyzed the time taken by this algorithm, and the output that we got here is 2n plus 3. How? In the last video I explained you, but I am going to explain it again. That is, here how many ones we have right now. This is the first one, this is the second, and this is the third one, right? So we have the 3 n's, but with that we have 3 ones, but with that we have 2n, right? So how we are going to get the output? And the output that we are going to get is something like this. We are going to give the f of n. Now if we have done the polynomials, or if we have done the maths, then you may be learning about f of n and all of the stuff, right? P of x, there will be there in the maths, but here we are going to use the same method, and that is f of n is equal to 2n we have, right? So how many n's we have? We have the 2n, but here we are not going to write here the n into n square. We are not going to write n square, and the reason is that n square is going to be n into n, but here we want to add the 2n's. How do we add that? But for adding the ones we get the output 3, but for adding the ones we get the output 3, but for adding the n's we don't know the output. So we have given the value, we have given it as an n because the value keeps changing. So that's why here we are going to call as 2n, or we can give as n plus n we can give there. If we write like this, then it's going to be multiplied, right? So we can give n plus n. Now anyhow we have the 2n plus 3, right? We are going to give the 2n plus 3. So the output that we are going to get here is 2n plus 3, that you can see here right now. Now here, what is the degree of this one? What is the polynomial of this one? So the polynomial of this one is going to be the O of order of n. So here right now I am not going to call it as big O notations, theta, all of the stuff. I am going to talk about that later on, but here right now we are in the basics, right? First of all, that's why I am going to call it as order of n. So that's what its degree here. Now let's analyze the space taken by this algorithm, right? How do we do that? Here if you see, first of all, for finding that, here we have to find how many variables we have right now, right? So here basically we have the a, so which we are giving as an array. We have the 8 7 5 6 9 5 6 3, right? But here we have another thing known as n, so which is going to write the number of elements in that array, in that specific array. Now here we have the s, which is equal to 0, and then we have the for I in range, which is n, all of the stuff. Now we just need to find the variables. We have the a, n and s, but here another one which is I. what is the use of I? For I in range we are calling the n, right? So here we are giving the n as range, and here we are giving the I here. That's why here we are calling the I as n as a variable. Okay, now let's analyze the time, let's analyze the space taken by this Python program, this algorithm. So how do we do that? So by finding how many variables we have total 4 variables a, n, s, I. So let's write out that here. Now coming here, okay, so we have a, n, s, I. Okay, so here what is a, right? A is an array. A is an array. What is n? N is number of elements in that array. But what is s? It's a variable. Now what is I? It's also a variable. Okay, so here we have all of the stuff, right? But here what is the use of a? So here in the a we have the array, and in the n we have the number of elements in that array. But here what if we do that? If we don't find the value of a, will we able to find the value of n? Will we? No, right? So the reason is that n is the number of elements in that specific array, but if we don't have the array only, how do we find the number of elements in that array, right? So that's why here a and n are based on each other. That's why we are going to give the a as n. So we have 1n. Now the value of n is, if we don't find the value of n, but we can find the value of a, right? So it's no problem here right now. Now here we can give it as 1. We have the s, which is also 1, and we have the I, which is also 1 here right now. Now here how do we calculate this one? So before that, while finding the time complexity or having the two n's, right, we give them as 2n, right, instead of giving n plus n, right? So here we have given, there we have given that 2n, but here we have only 1n, and we have how many ones? We have 3 ones, which is 1 1 1, which is going to be 3. Now here what we can give is s of n. Space complexity of n is going to be n plus 3. N plus 3. So this is how we find the space complexity. But here what is the degree of this one? What is the polynomial of this one, right? And that, so here we have written the polynomial, which is Sn equal to n plus 3. But what is the degree of this one? So I'm going to give it as also order of n, which is going to be the order of n only. But here we are not going to call this as the big O notations or theta, all of the stuff. We will talk about that later on. So here we didn't learn about that. We will learn about that later on. That's why I'm going to call as order of n. Now here what have we done? We have find the space taken by this algorithm. So anyhow guys, that's all for this video. I hope you liked and enjoyed watching this video, and don't forget to like, share and subscribe. And from the last video and in this video we have learned about space and time complexity. In the next videos I will try to talk about time complexity. So thanks for watching this video, and don't forget to like, share and subscribe, and I will see you all in another tutorial. Thanks for watching. Thank you. Bye bye.